Welcome students. In this topic, we will learn about T-joint on 10 mm thick MS plates in vertical position using SMAW process.
At the end of this topic, you will be able to select appropriate electrodes for tack welding and welding process. Prepare and set plates in T-joint in vertical position. Tack weld T-joint in vertical position using SMAW. Inspect the weldments for defects. Now, let us look at the tools required for T-joint on a 10 mm thick MS plate in vertical positions using SMAW process. Steel rule, scriber, prick punch, ball peen hammer, flat file, bench vise, tri-square, tongs, chipping hammer, steel wire brush, electrode cable and earth cable, electrode holder, electrode, personal protective equipment, SMAW welding plant machine, C-clamp. Let us see the pre-welding preparations for a T-joint on 10 mm thick MS plates in vertical position using SMAW process. Cut two 10 mm thick MS plates, 150 mm length by 50 mm width. File the edges and inspect the plates. Set them one on the other, forming a lap. Set plates as a T-joint in vertical position and tack weld at both the ends. The lapping distance should be 30 mm so that there is no gap between them after tacking. Clean the tack weld by using a chipping hammer and steel wire brush. Keep the electrodes ready for each run. For root run, use 3.15 mm electrode and 110 amps current. For second and third run, use 4 mm electrode and 160 amps current. We have seen the pre-welding preparations. Let us look at the welding process of a T-joint on 10 mm thick MS plates in vertical position using SMAW process. Use personal protective equipment for safety purposes. Position the joint vertically in the welding positioner. While depositing the root run, start from the lowest part of the workpiece. While depositing root run, ensure deposit of weld metal on both the plates by giving a slight weaving motion up and down the electrode. Use whipping action for the electrode. During whipping action, the electrode is raised away from the molten pool a little with a long arc and again brought back closer to the molten pool with a short arc. When the electrode is raised from the molten pool, the weld metal cools a little and partly solidifies, which helps in reducing the sagging effect of the molten weld metal. Move the electrode from side to side and stop for a short moment at each side to avoid undercut. Keep the angle of the electrode as shown to deposit the metal at a proper place in the joint without sagging. Deslag and clean thoroughly with a wire brush. Select a 4 mm electrode and set 160 amps current. Deposit second run with short arc using a weaving motion and uniform speed of metal deposition. Use a zigzag or triangular movement of the electrode. Use short arc length and stop a while at the sides to fill the weld at the toes. The electrode tip points upwards due to the electrode angle. The use of short arc and the weaving technique will control the sagging of the weld metal and the slag inclusion. The stoppage of the electrode at the toes of the weld for a moment in the weaving motion will help to avoid undercuts. Remove the job from vertical position and inspect the weld to ensure proper crater filling. Now, we will look at the important points, the defects, to follow for a T-joint on 10 mm thick MS plates in vertical position using SMAW process. Avoid over deposition and side undercut by using a proper angle and travel speed of the electrode. Avoid undercut. Ensure proper crater filling. Use tongs to hold the hot weld. Wear chipping goggles for the protection of eyes. In vertical welding, the problem to overcome is the inclusion of slag in the weld metal. These are avoided by using a short arc and proper weaving technique with a correct electrode angle. Let us look at the defects which can be identified during the inspection process. Solid inclusion. Over deposition. Undercut. Blow holes. Recap.
In this topic, you have learned to fix the joint in a vertical position, select the right electrode, deposit root run in vertical position, ensuring root penetration. Inspect the weld for surface defects.